All right, welcome everybody. Thanks for coming out on a beautiful summer night. My name is Luke Melia. I'm your host tonight. This is the Ember.js meetup. If you're in the wrong place, now's the time where you're welcome to hang out and have some pizza and learn something. So tonight we have at least 4 speakers. Our fifth may arrive in time. And the two kind of twin lead talks tonight are both around the topic of promises. First, we're going to have Dominic talking about promises in JavaScript and programming in general, concepts in action, et cetera. And then Steph is going to talk about promises in Ember in particular. So if you have been using promises for a while, or if you're brand new to them, you're guaranteed to learn stuff tonight. Super powerful concept that I'm excited to watch myself. I've got a few announcements, and I want to open up to any announcements that you guys have as well. First announcement is a big thank you to Pivotal Labs, who hosts us here, provides pizza and drinks, and has been doing so for over a year now, which is awesome. Pivotal, for those of you who don't know, is a agile consultancy with offices here in New York, San Francisco, Boulder, a few other places that I'm forgetting, I think. If you they specialize in Rails and iOS and do a bunch of other stuff as well. So if you either need consulting work or you're interested in working for one of the top agile consultancies out there, you should inquire about Pivotal. I want to draw your attention to an upcoming event that is next week that I have up here. We're calling it a fireside chat with Ember. Ember fireside chat. Yep. And it's with the core team members, not member. Nope, that didn't work. Core team. Oh, I'm out of characters. 1 character over. More. We've all gotten pretty good at that in the age of Twitter. So this is going to be an awesome event, I think. Yehuda and Tom are going to be in town. For those of you who don't know, Yehuda Katz and Tom Dale are the original creators of Ember, kind of presided over the fork from Sprout Core, and are members of the core team. They're going to be in town next week doing a training session, a 3-day training, which I know several members of the community are attending. And I know that Yehuda and Tom have been working hard on that and learning a lot from the trainings that they've done so far. So we figured we wanted to do something special while they were in town, and we decided a cool event would be to do kind of a fireside chat Q&A panel discussion with all the members of the core team that we could round up. So we've got Yehuda and Tom and Leah, who are going to be in town. Steph, who lives in New York, is on the Ember core team, will be here, and we've got Chris Selden to fly in from Seattle for the week as well. So I think we've got 5 of 8 or so. Which is a pretty good representation. There are special RSVP instructions for this, which some of you have followed, some of you have not. And if those of you who didn't and want to come are probably still on the wait list. Basically, on the meetup page, there's a link to Google Moderator page. You want to go there and ask a question. This is to make my job easier at the event, and to also make sure that the questions that you all have for the core team get answered. So there's a bunch of great questions in here. Add one, and then I will approve convert your status from waiting list to attending. So that's that. There is a cap on that. We're having that event at Harvest. The space is unavailable. Harvest can accommodate 100. I expect that we are going to sell that out. It's free, so I don't know if you can still sell it out, but we're going to be full. So if you are interested in attending, I think it's going to be great. I would recommend going through the steps tonight to get yourself secure a spot. Our other sponsor is my company, Yap and Yap Labs. Yap Labs is our Ember consulting arm of Yap. So if your company needs some help with an Ember project, or if you're interested in doing some Ember consulting, either as a full-time member of our staff or on a subcontract basis, talk to me for either of those topics. Announcements from anybody here. Events, people hiring, people looking for an Ember job. All of that is valid, as is almost anything else Ember related.
My name's Alex. I have a friend in Philadelphia, Claire, who needs a developer to work on the site for her art gallery. It sounds like a good job for Ember. So if anybody needs some freelance work, talk to me. She's looking for someone. And she's awesome.
Thanks, Alex. Anybody else? Okay, cool. Great. So our first speaker tonight is going to be Mike Rosati. And Mike is going to, Mike is the CTO of a company called Red Rover, who's been hosting some of our hacker hours. You can get set up while we're talking here. And I can't remember what the lightning talk is about now.
No, me either. I want to figure it out as I go. It's like Google Spreadsheets and pictures.
That's right. So Mike's been doing Ember for a while now, and has recently done some Ember data work to work against a Google Doc spreadsheet as a prototyping tool. So he's going to share with us tonight how that worked, and go from there.
Do it with one hand. All right, so at Red Rover, we have probably pivoted more times than I can imagine. I guess when maybe I showed you guys some Red Rover stuff a long time ago, we were kind of like Pinterest for the enterprise. It was very content managey. And what we found is that getting adoption on that is the hard part, because it's kind of like a vitamin, and what good is a wiki or anything like that unless a bunch of people are using it. So we started playing around with the idea of what if there were just these community manager type processes that would help people onboard onto the platform, like you have in a lot of things, right? And the more we started doing that, the more our clients started really liking having those and having ideas about what those might be and what they could do. And it kind of just took on a life of itself, where to the point now, we don't really even talk about the content management product. We really talk about it as we sell bots that automate rituals that your company has. So if you want to find out what different rituals AppNexus has, they're growing really fast. They went from 200 to 600 people in the last year. How do they do that without going completely insane? Well, the answer is they have a bunch of little hacks that they do. Like they'll email everybody after their first week and say, what do you wish you knew on your first day? And then whatever they reply goes into what they tell everybody on their first day. And it's not like that's that hard to do, but are you going to do it? Like, no, you're going to forget about that, and it's just not going to happen, right? So if you have a library of those things, then you can just say, I want to do that, I want to do that, and I want to do that. And then it's as if you hired people whose job was to do nothing but that thing. It'll email your teammates. It'll make you do things that you wish you had done or wanted to do that you maybe think would be good, but you forget, and they're not that important. So like we use it today for our stand-ups, because we used to just show up at our stand-up meeting forgetting what we'd done the day before and just waste a lot of time on nonsense. And so now, like 15 minutes before our stand-up, it emails everybody, says, what'd you do yesterday? What are you planning on doing tomorrow? Everybody fills it out. It calls out anybody who doesn't. And then our stand-up meeting is just going through this stuff, and it makes it ridiculously faster, so you spend less time meeting. Right? So that's the idea, but it's just an idea. And talking to our clients, we got right now something like 80 ideas for bots, right, that we've collected and we put in this big Google spreadsheet. And I don't want to write a whole new app for looking at those ideas and figuring out which ones have market pull and which ones are just like ridiculous and nobody really wants. So a couple days ago, we're like, well, how do we get something like that live really quickly? And so Ember's the answer to everything right now, so we're going to do something in Ember. But I don't want to build a whole new Ember app that has a data source that hits in a real database with just the bots that we've really written, because I want the fake bots, the ones that are just ideas that Kevin's throwing in the spreadsheet. And if I put them in fixtures, then every time we have one, I'm just going to have to update again. So I started Googling around. I found out about this project called the Miso project, which is really cool. It's for a lot more than Google Spreadsheets. It seems pretty well thought out. So like, I think it's by The Guardian. And it's basically like, how do I get into JavaScript a bunch of data sets from random places and then manipulate them in a reasonable way? And I think it handles like read, write, and then it'll do aggregate functions on them and stuff. Pretty cool. But one of the things they do out of the box is they'll connect up to a Google spreadsheet if you've given it a public URL, and they'll let you just suck it in. So I was thinking, what if instead of fixtures just being this array, it was an array that came from that, right? I don't care if I can't write to it, doesn't matter. And that way, the people in my business who are not technical, which is a lot, can just go and edit that spreadsheet, and then the site changes, and I don't have to think about it anymore. And maybe someday we'll get fancier. So this is the site running off of that on my local box, and this is the site running off of it in production. And if you edit the thing, it just changes like that, and it refreshes real fast, and it's great. So I was saying that using fixtures is awesome for developer, for prototyping. That's the first thing we should do, obviously. But once you want to take that prototype and actually launch it and get real feedback from real people, you're going to want to start editing stuff and changing and testing your hypotheses. And once you do that, you don't want the developer to be in that cycle anymore if you can help it. So I like to just kind of throw it over the wall and let people start gathering some feedback and then come back when they figured out what developer changes need to happen. And I don't know how to order things in this. So, so MISO data set. Step one, make a spreadsheet. I figure one sheet per model is probably the way to go. And just columns are the properties on your model. Make a basic Ember app. I think it should eventually be its own adapter, maybe extend fixture adapter, but I didn't do that. I was running out of time today. But basically, you have a model that just calls some method, just like you would find, only it's this magic method that you're going to write yourself. Like that. And then within that fetch method, I'm going to make a new MISO data set. And the only thing that's really interesting here is that key, which is when you publish a Google spreadsheet, it's like publish to the web, it gives you this key that ends up in the URL of the public version. So you just need that and put it there and say what worksheet you want. And then use it to fetch some data. So last minute I put in promises because I figured I had to for this talk. So I don't know if I did them right, but it works. So I make a new promise, fetch, resolve, and the MISO stuff is basically like on that data source you call fetch. It has two callbacks, success and error. And in the success, I'm then looping over each row of the data set and pushing a new idea object onto the array. Really? Woo! I learned how to do it. And that's it. I mean, it's really dirt simple. I'll probably wrap it up into something that people could just download as an add-on or something. And I recommend you use it. Also, if any of you guys want anything automated or have ideas, right now we're collecting them. So, let me know. Just Twitter, or GitHub, or email, or whatever.
Or you can just go to the spreadsheet and fill it in.
That's true. It is public.
Awesome. Thank you, Mike. Any questions for Mike? All right, cool. Good stuff. Thank you. That's awesome. It's very cool to learn about MISO. And it's also cool, I think, just as a real simple example of what it's like to integrate other JavaScript libraries into Ember. But that was pretty straightforward. So next up, we have a blogging maniac.
Tell me about it. I didn't lose a bet, but I made a bet.
So Matthew made a bet, which he can tell you about at the bar. Yeah. I think it's alcohol related. But Matthew's been blogging at madhatted.com. You probably, if you've been following Ember news, you probably have read some of the stuff he's been writing. And if you haven't, then you should check it out. But one of his posts was about a library called Share.js. And that's the lightning talk that he's going to share tonight. Cool. And I'll give you're all set. Awesome. Give me a testing into that thing.
Hello, hello.
Try putting it right a little closer.
Hey. Can anyone hear that? No, nobody can hear that.
Are you live coding? Or?
I am live coding.
That's
Okay, cool. Yeah, so I am live coding. I apologize, but I think I have a couple things together, so it should look pretty all right. So, I had a blog post that I put up just a short while back about ShareJS. And basically it was ShareJS is a platform for doing operational transforms. So it's written by a guy who used to work on Wave and some other services. But it lets you take two text fields or two things and then synchronize changes between them. And the way it does this is by like versioning every request. You say, oh, I previously had this data and I had it in like this location. So if I have the sentence, hi, I'm Matt, I would send a message to the server saying, I'm going to change word number 2, and it's going to change from I'm is the old information into you, and it would say, hi, you, Matt. So then the other side of the connection would like have that message transmitted down to it, and yeah, so that's the basic idea behind operational transforms. In particular, I'm using a tool called ShareJS, and ShareJS handles a lot of the grunt work for you. I know everything's really, really huge here, and I have a million tabs, but it should be pretty easy to pull up. So they allow you to do operational transforms on things. You can type into this field, and like anyone else who's in the world can see me typing into this field, and it all happens automatically. On the back end, they use Redis to take the changes and then publish the changes out to other locations. So a framework called Derby, like 3 weeks ago, came out, and they had some big post on Hacker News. It was like, whoa, Derby is the first like operational transform framework. And I was like, that's like BS, because Ember can do it too. So I made a quick blog post that created, yep, 5 million tabs. They do not make a laptop with enough RAM for me. Yeah, so this is the, I just zoom this, are they doing this? This isn't it. This isn't it. Yeah, okay. So I made this one called Emberpad, and Emberpad just takes Emberpad just takes this text area, and it has a body here. Load in ShareJS, which is a little bit tricky, which I talked about, and then there's some weird stuff here. But we take this apply change. Apply change takes the old value, which is text, and the new value, which is the new text, and does all this mess to find out what actually changed, so that when it transmits it up to the server, it can say only that I'm changed into you, and none of the other stuff surrounding it. It doesn't want to send all the information, because then if someone else was changing it at the same time, there'd be a good chance that you would conflict with each other. So this is how you're less likely to stomp on someone else's feet. So it creates this little Ember application, just sets the body to be nothing, and then it does all this messy stuff to actually talk to ShareJS. So it sets this doc, and it has this remote op. You connect in ShareJS, and I'm connected to a text, and the document is app body. And then here we go ahead and we respond to remote ops. So anytime anything happens on the server, a remote op event gets fired here. And whenever that happens, we just take this doc snapshot, which is actually the whole text document, and drop it right in to be the value of whatever down here of the actual body. So this is kind of cool, but doesn't really give us operational transforms, because every time someone on the server sends down a whole document, like, you replace the whole thing on the client. So if they were in the middle of editing something and it hadn't synchronized, you would have blown away their changes anyway. So this is also not totally ideal. And it's just kind of messy. So as a next step, I thought it would be better to not do it with just a text field, but actually use objects. So ShareJS supports the idea of not only just plain text documents, but I have a JSON document, and I'm going to change something at this path. And then inside of that path, say that path is an array, I'm going to insert an element in like the second position in that array. So it actually lets you do these very specific transforms on more complex data structures. So that ended up being a little bit nicer. So we're going to have a text area, which is our body, and a value binding, which is going to be places string. So places is going to be an array of content, and the string is just going to be a computed property that kicks out the string. Places count is a count of the things. And then down here is our router, and the router just uses activate and kind of hacks around. The shared object I'll talk about in just a minute, but it basically opens up a document, and it can be named whatever. It's called application model, and then has a promise. The promise accepts the model and actually sets it on the application controller. The application controller has a places string, which is a computed property, and all it does is look at places and join things with commas and split them with commas to actually store it as a structure instead of as a flat string. And then places count just looks at places and actually looks at the length of what's going on. So we can show the length. Cool. So if the gods of live coding are with me, then I should be able to load up this guy. And you should be able to load up, oh, yeah, I'm sorry. So I actually tried to put this on the local network at this address, and I don't know if that will work for any of you or not. I kind of think it might not, but You know, you let me know. So this guy right here will allow us to type, and we're just going into a local Redis database and everything. But this is text, and this is kind of what we had before. So cooler is if we can do this with complex data structure, which is kind of neat. So when it's sending this back and forth, it's actually sending back and forth an array. It's not sending back and forth like an actual string. It's saying, I'm going to inject a new element at the end of this array. I'm trying to remember where I can show you what the transforms look like, but I don't recall off the top of my head. But, so what's kind of cool here is that all we did was take this object and start watching, and then it kicked in the object once it was finished connecting, and then we just dropped it into place, and that's just normal Ember bindings, like taking care of propagating it.
So do you flash the whole array, or is it just does it turn into like a single element of your
I'm doing it kind of naively and notifying the change on the whole array.
I mean, the notifying, is that on the Ember side, or is like what's
Yeah, so what's happening in share object here, this watching is our kind of like set up the connection. So we just make a promise, and we open up our connection. We open up a connection with a type of JSON, and the doc is our name of our document, which is our application model that we passed in. Inside of a run loop, we go ahead and create a new instance of the shared object, and then resolve our promise and kick it in. So that's just creating our connection and opening our document. And when it creates a shared object, in the init function here, it takes the doc, which was the actual document object from ShareJS, and then we go ahead and we listen on remote ops once again. And remote ops have this data structure of all the operations that are going to be performed. And then there's this p value, and on p, there's all the keys that actually changed. So because those are just keys that are on the Ember data object itself, we can use this nice little property did change function, which is how how properties work in Ember. That's how something else knows that something changed. So we just call that, and we say, hey, this property changed, which is what tells the view to update the binding and everything else. So it actually happens pretty transparently. And then these actual unknown and set unknown properties down here, they look a little bit complex. They're really just acting as proxies down to this subdoc.get. So subdoc.at, the underscore doc.at is saying, asking ShareJS, the ShareJS document, at this path in your JSON, which is just the top level for right now. This is the node that I want off the JSON document. And then .get says, just give me the value, because by default, you get another document that you can then call add on again and again and again. So that just returns that. And then every time we get something from the server, it just handles the change notification through property did change. And voila, our UI updates, which is pretty cool. So now Ember is the second operational transform powered framework if you dare install my code on production. So I'll probably put this on another blog and on GitHub or Heroku or something cool so people can poke at it.
Awesome.
Questions?
Questions for Matthew? I have a question. Has this given, as you've been experimenting with this, have you had any particular ideas for types of experiences that you might want to create?
There's all kind of neat things. The most eye-opening thing was actually the BC socket library up there is a library that's used by ShareJS. It's kind of comparable to Socket.io, but it's far more reliable. So it's not as performant because it uses long AJAX polling, but it's a way to send messages to the browser and for the browser to send messages to the server, where it guarantees the messages will arrive in order. And you can send messages, and then if you don't have a connection, and then you make a connection to the document, it'll propagate all the messages. So compared to things like Socket.io, where if it's up or down, you have no idea what's going to actually arrive on the other side, this is much more reliable. So I think that's been the main big takeaway.
Awesome. Question over here.
So right now you're just sending basically browser to browser. Where would you consider putting in persistence in this? Let's say if I actually want to save the contents of that box.
So the question, let me just repeat the question. The question is, this demo shows browser to browser syncing. If you wanted to persist this stuff back into your backend, where would you hook into the server?
So ShareJS actually takes care of a little bit of this. Yeah. So this is basically the Node.js app that powers ShareJS. And you can see it's super simple. You just down at the bottom here, ShareJS attach to like a server or something. And they support a variety of backends that do PubSub. So amongst them, Redis and Mongo and I think something, CouchDB, like a couple things. So yeah, you could implement this all on your own, but the whole point of ShareJS is like you do not need to think about the operational transform stuff too much. They will take care of doing all that transform so long as you just give it a database to point at, and on the client side, you like react to the events in an appropriate way.
Cool. One more thing. I like your T-shirt.
I like your haircut.
Yeah, thanks. Awesome. Thank you, Matthew. We got Alex next up. So Alex Machnier, this should be on. Alex Machnier recently has been one of the hardest working people in Emberland. And so he's going to do a quick summary of the most recent thing that he's been working on. And then we're going to have him back in July for a more in-depth talk on this topic. Right.
Is this working? Good. I'm Alex. I've been working really hard on this enhancement to the Ember router, codenamed the router Facelift, and basically started probably about a little bit more than a month ago, because I work on these Embercasts with Eric Brandon. We've been a little bit long delayed in publishing the next one because I've been working on this thing, inspired by this particular Embercast I was trying to get working. All right, yeah, so like I said, it's been codenamed the router Facelift, and it's on Ember Master right now, and it's going to be on RC6, which is probably going to be this weekend. So hopefully by this weekend, you'll be able to just go to Ember.js.com and download the starter kit, which comes with all this new stuff. And as well as RC6 coming out, there's also going to be an Embercast, which kind of reinforces a lot of what I'm going to be going over really quickly today. Basically, for the uninitiated, the Ember router, any idea why it keeps on doing that? Come on. All right. So the Ember router is pretty much the backbone of every Ember app that you will ever write. It is responsible for linking application state to specific URLs. So as you navigate around your Ember app, you'll see your address bar changing, and ideally at any point you can just refresh that page and wind up exactly where you were started, or how you got there. Sorry. You can refresh and wind up exactly where you just were, and it'll load all the same data just from deserializing from this URL. And it also just manages a lot of complex logic that's otherwise pretty cumbersome to deal with, such as rendering into these deeply nested outlets as you start having these routes that are children of other routes that are children of other routes. And in the last 6 months or so, it's had this lovely DSL that you can use. It's just really great for just quickly laying out your application and all the nested pages and routes and states and so on and so forth. But it had a few limitations. Probably the most important limitation, or the one that was hardest to get around, was some limitations involving some async data. And the theme of tonight's Ember meetup is promises. And promises are a really elegant solution to dealing with async problems, and that's definitely made an appearance in this sort of Facelift API. And another limitation, which is sort of related, definitely related, is in times where you actually needed to have some sort of async logic happen, or maybe you're waiting for a response to come back from the server to decide whether or not you can even enter a route, it was really hard to handle those cases. You would pretty much leave the route that you were originally at, and then if something went wrong, you had already left, and there was just a lot of use cases involving this kind of seal proofing that were pretty difficult to handle. And another thing that was pretty difficult to deal with is if you ever press the back button while you're on a certain route, there's really no good way to prevent that from just obliterating whatever form the user might have been working on at that time without doing some pretty substantial hacks. And also, just whether there's kind of two different transition types, for what it's worth, when you're working with the router, and one is just URL-based transitions, like what I was just talking about, and the other one is using transition 2, which is just kind of the internal way of giving the name of the route that you want to go to rather than the URL. And the way those two different types behaved were, the two transition types behaved were pretty different before in a way that was hard to get right the first time. So the solution to all this was to, one, unify those semantics between the internal transition to and the URL transitions. Second was to just embrace async and particularly promises, which we'll be talking more about tonight. There's also some events that are fired along the routes, which, the events have already existed within the Ember router. It's you fire an event on the route, and it'll start at the leaf-most active route and then bubble upward. And basically, the first route that handles it is the one that decides how that event is handled. So we reuse some of that for, in particular, the events will, transition, and error, which are new, to kind of preserve that bubbling configurability. And also, we allow for transitions that were aborted to be retried later. And I'll show you an example of that in a little bit. I pretty much just told you about this page, and I don't want to spend too much time on this. But basically, transition to and URL-based transitions will be the same, and you'll be a lot less surprised when you get one working. The other one will almost certainly work as well, and that was not as guaranteed before. This is a sort of important conceptual difference. I wish there was a better name for it, but there's this new phase before any of your templates actually get torn down, and the new templates for the destination route get built up. And this new phase is called the validation model resolution phase. And if anyone is good at naming, we have a few other outstanding issues involving naming with the Ember router that need to be resolved, including this one. So please let me know if you can think of one. But in this phase, it's possible to redirect or abort or decorate the transition, put some information on the transition that maybe later hooks will be able to respond to and act differently based on that. And the two main hooks that are added, in addition to the pre-existing model hook, which is used for, the route uses this model hook to actually say what data needs to be loaded for that route. You have before model and after model, two hooks that don't really have the 100% approval of everyone as far as how they're named, but for now, that is how they are, and they'll probably stay that way for a little while. And it's these hooks that make use of promises. Again, I don't want to speak too much about it because that's the theme of tonight, but you can pause a transition and wait for some data to come back before deciding whether that transition can or cannot take place. So I talked about these two events that have that bubbling characteristic. And the first one, which is really useful for having a, if you want to have the present routes stop a transition from happening, you can define a will transition event handler on them and basically have the route that catches that say, okay, is the controller ready for this thing to navigate away? And if not, you can call transition.abort. I have this example up here, which, assuming that we have some property on the controller called can navigate, if it's not true, then you can say transition abort, which will just, it won't redirect the transition, it'll just stop it from happening. And that'll catch both URL-based transitions and normal internal transition twos. So that's one good use for it. The other really important event, which is new to this Facelift API, is the error event. And so those hooks I was talking about before in the validation phase, before model, model, after model, if any of those return a promise that eventually rejects, or if there's an error that's thrown within one of these things, this event error handler will get fired. And because it's an event, this error event will also bubble. So if you want to have some error handling logic on a parent route shared between a bunch of other different child routes, you can just put that error handler on the parent route, and it can just be in charge of all those different specific routes, errors and promise rejects, and so on and so forth. In this particular example, I have the model hook is the one that's responsible for getting data. And if the getJSON request fails, then you can check this reason object, which is what gets sort of returned or resolved by this failing AJAX promise getJSON that getJSON returns. And you can check its status, and if it's a 401, as if you try to get some data that you're not authorized to get, then it will redirect you to login. And otherwise, this isn't as well known of a feature, but if you're in an event handler on a route and you want to bubble it up to the parent route, even though it was caught on this one, you can return true, and that will continue to bubble upward. And lastly, I'll just show an example of this, but if you abort a transition and you still have a reference to it, you can call transition.retry, and that will kind of restart that transition. So I'm going to do just a quick demo of what this can do. This is pretty simple of an app, but a lot of this stuff was pretty tricky to do beforehand. So here's a little app that has a home page and an articles page. And the articles page can't be visited until you log in. So when you click this, it catches that you're not logged in and redirects you to this login route. And also just demonstrating another feature, which is now a lot easier to do. If you type in something and you try to go back to home, for instance, it says, well, where do you think you're going? But really, it's just catching the fact that you have a half filled out form and it's not letting you continue onward until you, I guess, clear something. I mean, this is just a demo. You probably want to do some other thing here. But if you log in, it says you're logged in. And the last feature is that it redirects you to where you're originally trying to go before you are redirected to articles. So that's also exercising this retry capability. So let's take a quick look at the code and we'll be finished here. So articles route, this is what gets invoked when you try to navigate to that articles page. Remember, there was that. Oops. Sorry, let's have this up and running. So this articles route corresponds to this articles link. And this before model is one of these new hooks I was talking about. And before model is a great place to put any logic that needs to happen before you actually try to get all the data that route needs to display in its templates. And all I have this before model hook doing is checking the login controller and it asks it, has the person logged in? And if not, puts a little message out. It sets this previous transition to this transition object that was passed into it so it can remember it for later. And then we just transition to login. And that effectively aborts the transition. You don't have to call transition.abort if you just transition elsewhere. It'll catch that too. And going down to login controller, this little function here is just called from the template, which the template is not too important to look at. But when you, let's see here. Remember there was that functionality where if you have something filled out already and you try to navigate elsewhere, it'll catch that and it'll say, where do you think you're going? And anytime you see anytime the current route that you're on is preventing a transition from happening, it means that it's being handled in this new will transition event. And this one's also pretty simple. It says, can the login controller navigate? Which is pretty simple logic here. You can navigate away if you've already logged in or the form doesn't have any data. And if you can't navigate, this will call transition abort and chide you for trying to navigate away. And once you actually do click this login button, it will give you a little message. It'll set has logged in to true. And then it'll take this previous transition, which was set up here in the articles route before we redirect it to login. It'll get that transition and call retry on it, which is how it knows to go back to articles after you've logged in. So hopefully, particularly if you've ever had a fight with a router before, you'll see how this simplifies some stuff. Makes certain things that weren't quite possible before possible, if not, or if they were possible, they're certainly a lot more easier to wrap a brain around and less hacky. But that is the extent of what I've been working on. And just some final thoughts is that all of this whole change was a very collaborative effort. I've been talking a lot with lots of people on Ember Core. I've been talking a lot on Ember Discourse about it, which I believe is discuss.emberjs.com. It's a forum that's powered by Ember, where some possible API changes are discussed and worked through, and got a lot of help on that, just fleshing things out. In particular, a lot of help from Luke here, and a guy named Sebastian Salen from San Francisco to help work out some of these final API ideas. And yeah, the code's on master right now, so if you want to sort of live on the edge and give it a try, it's definitely ready to go. And this week, by the end of this weekend, it should be on RC6. And also, with RC6 is going to be an Embercast on authentication. There's already a part 1. There's going to be a part 2 that uses a lot of stuff discussed today. And that'll be up by this weekend. So yeah, any questions?
Questions for Alex? Andre?
How much was inspired by trying to write the second part of your book?
100%.
The question for the folks at home is how much of this was inspired by trying to write the second part of your authentication Embercast?
A lot. Yeah, I mean, it was absolutely the inspiration for it. It was done. It was ready to go, but I didn't feel right about it when I figured there were some things that could probably be improved about the API itself.
Something was going by in one of the pull requests for this where everybody was saying, like, let's test head on master on a couple of complicated apps and see how things work and what breaks. So do you still need that? Because I mean, we did it with ours and it seemed to be fine. But maybe everybody could just try Ember latest and see if it busts stuff and let you know before we roll it in.
There's been a lot of people trying it out, and Luke tried it on Yap pretty early and found a few things that were weird about it that have already been corrected, but a lot of people are using it and pretty happy with it, and I'm happy. It was designed to be pretty backwards compatible, but there's some semantic differences that I figured would catch people off guard, but it's been pretty good.
Most of the stuff that we've heard so far from people have been people able to rip out hacky code that they had before. That's great. Cool. And so I think Alex and I are going to talk about it, but I think next month we're going to do a sort of overall router tutorial that Alex is going to present. So that'll be an opportunity for more questions if you've got them about router, which is, you know, as Alex said, kind of the backbone of any Ember app and is really valuable to learn at a pretty deep level. Will make you a much more capable developer. And I just want to say thanks. This was, in my opinion, this was one of the big blockers for Ember 1.0. And Alex really persevered and tackled some very challenging problems to deal with this. And so thank you very much.
No problem.
Appreciate it.
Thanks.
All right. Next up, we've got Dominic. All right. Awesome. So you know how you run into people in life who have passion around a particular topic? Maybe it's your brother-in-law, he loves baseball. Maybe it's your sister and she loves race car driving. I don't know what it is, but I do know that the gentleman who's standing up in front of us at the podium has some passion around the topic of promises. In fact, when Ember started to dip its toe into promises, we got a couple of things wrong. Dominic let us know quickly, clearly. But what the thing that's awesome about that is that it started a relationship between Dominic and the core team that's been really productive and fruitful and helped to not only make Ember's promises implementation more solid and the RCP microlib that I'm sure Steph will talk about, but it's also helped to, I think, inform the wider discussion around promises and how we think about them. So if I can get your undivided attention up front, that means quiet, you in the back in the green shirt. We're going to get rolling. Ladies and gentlemen, Dominic Nicola.
All right. Hi, guys. Happy to talk to you about promises. As Luke said, something I'm passionate about. So this is me. I do a lot of open source stuff. Check it out on GitHub and NPM. And especially check out my SlideShare, I think, if you're interested in promises, because I've done, at this point, way too many talks about promises. It's kind of a problem. But I have presentations that go over different aspects of promises, like the thing that Luke was talking about, how Ember started with promises and how it was all off, and that actually started the entire Promises A+ movement, which is just a standard organization I'm part of. And there's a lot of really kind of interesting aspects you can approach the problem from. Like I have one that back from my .NET days when I was transitioning over to JavaScript, and I'm like, oh, what is asynchronous programming? And so it goes all the way from like, oh, well, you've seen the Win32 event loop before, so it's kind of like that. So I mean, I think I'm not going to spend a lot of time this talk on either the historical aspects or on the how does asynchronous programming work? How does callbacks work? We're just going to kind of dive into the conceptual foundations of promises. But if you want more, there's a lot more there. Other things that I'm doing that I think are especially cool, and I want to share with you. I have this Twitter account called ESDiscuss, where I summarize the mailing list where the next version of the language, JavaScript, is developed and discussed. So if you don't want to dive into the intimidating technical discussions, but you want 140-character summaries of what people are talking about, then that's for you. And I work on the Promises A+ spec, which is a community spec, which I gave a talk about at JSConf, which essentially standardizes the core of promise libraries that we see today. And this has been really successful, and a large part of it is out of the work we've done with RSVP, which is part of Ember. And we also, it actually informed the DOM promises spec. So promises are going into the DOM. They just landed in Firefox Nightly like 2 days ago. There's a bug open in V8, and there's some patches in progress. We're going to get promises in our JavaScript engines. And yeah. All right, well, probably should have ended with that. But yes, I'm also working on Q, which is a promise library that I've been involved in. It's kind of like one of the older granddaddy promise libraries. It's kind of ginormous. It's not as small as something like RSVP, but I like it a lot. We have a lot of cool features. So I'll be using RSVP in examples, but if you're really curious, I do suggest Q. So we have our obligatory ragging on callbacks slide. But kind of, I want to approach them conceptually, not just like, oh, my code is hard to read, callback hell, nesting, wah, wah, wah. Like, literally, the issue with callbacks is that they are the simplest thing that could work. When you say, I need to do something asynchronously, oh, I know, I'll stuff everything into a function that then executes after my asynchronous operation. That's what a callback is. It's not like, some base abstraction that is the foundation of our ecosystem, which, as some people claim, it's just like, oh, I will stuff things into a function, and then it will happen later. They don't have any of the guarantees that we would expect. There's no consistency. You could have a callback that calls back with 3 parameters, or one that calls back with 2 parameters, or there's no guarantees. You could get something calling you back with an error and a result, or it could call you back once with an error, and then once with another error, and then once with an error, and once with a result. Like, these are real bugs that you can see in popular web frameworks. I was at a talk in China in Hu.js, and I couldn't understand anything the speaker was saying because it was in Chinese. But I did notice that what he was doing was he was pointing out a bug in Express, a popular Node.js framework, where because they didn't wrap their callbacks correctly in a try-catch, it called back first with an error and then with a result. So that was pretty depressing. But that's a systematic problem with callbacks, right? And we lose the flow of our code when we use callbacks because we end up writing all these other meta callbacks that tie together our original callbacks so they can go do multiple things in response to a single thing, or they can go do 2 things at once, or things like that. And even worse, in terms of the amount of boilerplate we end up writing, we lose the call stack, the fundamental unit of our imperative programming language. The idea that functions call other functions and return values to your functions. And that functions can throw exceptions, and then those will bubble up the call stack until somebody's ready to handle them. And then you can handle those exceptions and continue, or you can rethrow them or transform them. Like, this entire paradigm that we've built up just gets destroyed when you move to callbacks, and you have to go to this manual continuation passing style with errors and some convention that's like, yo, error first, or whatever, or jQuery style, two callbacks, whatever. So promises are the right abstraction, is my claim. And you can see this historically in the amount of languages that they've cropped up in. They're in Python, they're in .NET, they're in C++, they're in pretty much every language that has adopted asynchronicity has adopted a promise paradigm. And they're ubiquitous across the JavaScript ecosystem. We have them, of course, in Ember, but we also have them in Angular. We have them in jQuery in the crippled form. We have them in Win.js, the Microsoft's Windows 8 platform. We have them in Dojo. That's actually one of the very first promise implementations. Like, they are ubiquitous across the ecosystem. And so, I mean, that's the argument from authority. But let's get into what they actually give you. So here's a basic idea, right? Instead of a continuation passing style where we pass it a function to do stuff, we actually get back a value called a promise for whatever we are doing. So that thing represents an eventual template. Like, we do our XXR, and it's an eventual template that we will eventually see. So one of the first benefits we see from this style is that we separated our outputs from our inputs. We're no longer conflating our parameters. Oh, look, we pass in the inputs to our function, but we also pass in the way of getting an output. Now we have actual return values, which you can imagine is a pretty useful thing in programming. But we also get back all our guarantees, because when you access a promise's value via this then method, so you have a promise and you call .then and you pass it 2 callbacks, only one of these callbacks will be called. So only the promise will ever only be fulfilled or rejected. And if it's fulfilled, it will only be called with a single fulfillment value. Just like when you have a function, it would only ever return you a single value. It would never return you 2 values. It would return you an array, a single array. Similarly, onRejected will be called with a single rejection region, which is usually an error instance. This is just like you can have a single error, a single thrown exception when you exit your function. You can never have both. You can never have both a return value and a thrown exception. Same thing with promises. You can never have both a fulfillment value and a rejection reason. And if a promise is already settled, meaning either fulfilled or rejected, then the handlers will still be called once you attach them. So this allows you to delay processing of your asynchronous operations until you're actually ready. So that's just a nice little side benefit, and we'll see that in use later. And a final guarantee, and this is something you see a lot in callbacks, is, or a problem you see a lot with callbacks, is that the handlers will always be called asynchronously. So we will never have code that all of a sudden you get interrupted. You passed it this onFulfilled function, and it calls you right back and interrupts your flow. So we'll see some examples of how that can interfere with your programming if that's not guaranteed. But promises give you a consistency that you will always get back an asynchronous value. So the way this method works is that promises can be chained. So it returns a new promise. If you have an original promise and you then onFulfilled, onRejected, you get a transformed promise. And the way that this transformation works is as follows. So you say, if the called handler, whichever one it is, whether it's fulfilled or rejected, returns a value, then the transformance promise will be resolved with that value. Now, resolved is a term that gets people confused because jQuery uses it to mean fulfilled. But resolved actually means like we're going to lock in the promise's state. So this means one of two things. If the return value, the value we're resolving to, is a promise, we will adopt that promise's state. So if you return a promise that's rejected, that means the transformed promise becomes rejected. And we'll see some examples of how this is useful. I know this is kind of abstract, but I want to give you the conceptual foundation. And if you return a promise that's going to take another 2 minutes to resolve, or sorry, to fulfill, or to settle, to fulfill or reject, then you will also, the transform promise will have the same properties. It will take that long. But if you return just a scalar, if you return something that's not a promise, then you'll get fulfilled with that value. So that's what to be resolved means. And also, of course, and this is a big one actually, if your handler throws an exception, then the transform promise will be rejected with this exception. So this means that you're safe from things like doing JSON parse inside of your callbacks. That'll just turn into an asynchronous error. You don't have any of these problems we do like with jQuery promises, for example, jQuery promises, where you get an error inside your asynchronous handler and it turns into a window.onError call and you have no way of handling that at all. So that's a big one. And I mean, similarly with callbacks, right? If you throw an exception inside your Node.js callbacks, then boom, process on, uncaught exception, server crashes. So the thing about this method is that it enables a very clear parallel to synchronous code. So in synchronous code, you would usually do something like this. You would say, here's my result variable, and I'm going to do one of two things to it. I'm going to either process the result and or I'm going to process the input and get a result. Or if there's an exception, I'll try and handle it. And of course, if handle error throws an exception, then that just goes out, right? So that's pretty much the analogy that we have over here. You asynchronously can process an input, or you can asynchronously handle an error. So what's really powerful about promises is this async-sync parallel. And this enables some really cool code transforms in ES6, which I won't get into. But more generally, it enables you to go back to thinking at things in terms of a call stack and in terms of chained functions and in terms of really more functionally than imperatively. And so with this parallel in mind, I want to go through a few cases of exactly what this means. So the first thing that you can do with promises is just a simple functional transform. Right? So you have a promise. So in the synchronous case, you have a user, and you want to pull off their name. That's like a function, right? It's like plucking off a property. Well, you can do the same thing with promises just by passing in a fulfilled handler that just plucks off the name property. So that's like the first thing you can do. It's like you're getting back your functional roots where you can just transform values. But the next thing you can do, it gets more interesting, right? If you get some condition that you're not prepared for, then you can turn that into an error. So in the synchronous case, you just say, oh, I see that. I'm going to throw an exception. Well, the same thing with promises, right? You get back a value that you're not prepared for. The user is null. Well, you can throw an error. And what that does is it turns user promise into a rejected promise. Okay? So now you have this error waiting around that will be ready for you to get whenever you say, oh, well, what was the result of that asynchronous operation? Making sense so far? All right. So and of course, you can do the other things that you do with exceptions, right? You can actually handle the exception. You can try to do an operation, but then you can catch it and then recover from it, log it, whatever. Right? And that's exactly what we can do with promises too, because we just don't do anything if there's a success. We pass an undefined for the fulfillment handler, but then we handle it over here. We don't rethrow it, we just handle it. We're returning undefined, so this is a promise for undefined. But more importantly, it's a promise that won't fail, because we recovered from any failures. And of course, we can rethrow the exception too, right? If you want to augment the exception or censor the stack trace or whatever, you can do that. You can say, I'm going to catch it and then rethrow a new thing. Same thing with promises. You catch it in the second part of the then, and you're going to rethrow with a new error. The final thing that you can do, and this doesn't have a synchronous analog. Well, I guess it does because I put one up there, but it's qualitatively different from the others, is you can wait for operations. You can say, I'm going to do this operation, this async operation, and then when that happens, I'm going to do another async operation, in this case updating the user, like up here. And then after that async operation completes, I'm going to go and refresh the UI. So this is making use of the resolve thing I was harping on, where you can return a promise from the handlers, and then it will wait for that to happen. And what's interesting here is just like in this code, right? If update user threw an exception, it would skip refresh UI and just bubble up so that whoever was listening for this knew it. Same thing here. If this returns a rejected promise, or returns a promise that eventually becomes rejected, then the overall promise that we're creating here will adopt that rejection. And this will get skipped because there is no rejection handler. It's just the first handler. So you can see that we're kind of getting a lot of power already with this async case. And I mean, in practice, well.
So quick question on case number 3.
Yeah.
Do you end up with, at the end of that, a fulfilled promise or a rejected promise?
You end up with a fulfilled promise here, because you have not rethrown the error. You have a fulfilled promise for undefined.
So that fulfilled promise would return undefined?
Yeah. It's a fulfilled promise for undefined. If you returned anything, if you returned 5, it'd be a fulfilled promise for 5.
On this special case for font.
Yeah. Oh. Yeah.
So does it short circuit the refresh UI? Doesn't even call it all unless there was a fail handler there?
Yeah, the question was, if there's no fail handler, yeah, does it just skip the refresh UI? And yes, no matter what. Because this is a fulfillment handler and the promise is not fulfilled in our hypothetical scenario where this fails, this will be completely skipped. You'll never see it happen. Just like up here in our sync code, this will never happen if this throws an exception.
Or a fail.
Exception. It's about exceptions. This is about exceptions and return values. All right, questions are good. Thank you for asking them. All right. So here's some key features that I think we can walk through in code examples, and you can kind of see some more practical promises in action as I just use them to demonstrate these to you. So the promises are always guaranteed to be asynchronous, which I mentioned is really important. And as I've started to kind of get at, they provide an asynchronous way of doing exception propagation. And so I'll give you kind of a very clear example of how that works. Then also it gets really interesting, and this is beyond just a parallel with sync code. Because promises are first-class objects, you can do some really cool stuff with them. You can combine them and do operations on them, combinators and things like that. And finally, kind of in contrast to how callbacks end up forcing you to work, you can create some really nice reusable abstractions that operate on anybody's promises. And I want to give you some demonstrations of those, especially so you can see how you work with promises more generally. So always async code. Well, so here's our example, right? And let's study this. Well, this is a callback example, so let's not worry about it too much. But you get the idea of something we're trying to do. We're saying if there's a cache, if the thing is in the cache, let's call back with that immediately, right? Let's get it from the cache and call back. Otherwise, let's go do the AJAX call and then call back with the success or the error or whatever happens. So the problem with this function is that the first time you call it, the cache is empty. So if you have a setup like this, what will happen is it goes 1, oh, OK, I got to do something async. Let me move on to 2, and then come back later with the user. But the second time you call it, right, because of how we've set this up, it's going to do 1, oh, well, I've already got that. Let me call you back right there. Dominic too. And so this kind of thing can lead to extremely subtle bugs. This is really, really problematic when you're trying to write tests, when you're trying to make your system behave in predictable ways. It can have things that can show up which only, this is exactly the kind of race condition and kind of sporadic bug that you would see in your system. That you probably have experienced in your system, those Heisen bugs. With promises, well, first of all, let's look at the implementation, right? This is how we would do this. We would say we want to always return a promise. So if we have something in the cache, we're not going to return the value or call back with the value, whatever that would mean. We're going to return a promise which is resolved to this scalar. Well, since it's a scalar, that just means it's a filled promise for that value. So we get the user and we return a promise for it. Otherwise, we do this promise-based XHR. And then we can just compose that in this really nice way. We return the promise generated by that thing. We don't have to kind of thread the callbacks through to each other like we did with the other one. So that's pretty nice. And of course, what happens here is every time, it's always going to be 1 to Dominic. Even if it's a really fast cache lookup, it'll just delay one event loop turn, or till the end of the current event loop turn even, which is an optimization that's pretty clever that people have been doing. So you really lose no speed, but you gain consistency in your code. All right, moving on. Or were there any questions about that example? Yeah. Yeah, that's fair. So the question was, I didn't quite get the mechanism by which it delays. So would it answer your question to say set timeout 0? I mean, that's basically what it's doing, is it's ensuring that, if somebody is attached to then handler, it never gets called until at least a set timeout 0 has gone by. And set timeout 0 is a simplistic answer because there's much faster ways of doing that, involving mutation observers and crazy stuff. The Ember run loop gets involved. But the idea is, yeah, we always delay. So we never let those callbacks be called immediately. Thanks. All right, so async exception propagation, right? So here's our code that we just coded up when we were happily coding in the land of no errors one night, in callback land. And it's a bit of a pyramid, but whatever. We're tough. We're JavaScript people. We know how to do this. And then we get a code review, and our code turns into this. And so now we're sad, and we're considering moving to Scala or Haskell or whatever, and everything's horrible. So that's sad. And then the Node.js people tell us to just name our functions, and everything will be better. And then we have like twice as much code, and that's even better. But if we use promises, then we can just do this, right? So the idea here is because we have this try-catch parallel, we don't have to handle errors until the end. We can just do operations in sequence. We have this thing which returns a promise, and then if it succeeds, we go on. We say get best friend. And if it succeeds, we say show the best friend. And then at the end, we say, well, if that succeeds, we're done. But if any of those steps failed, if any of them generated a rejected promise, that will flow in to the next step and skip those steps until eventually it finds an error handler. So there's the UI.error handler. So I think that's pretty stark example of comparing this to this. Oh, clicker. Yeah, comparing that to that of how promises will simplify your code. No. There are ways to get around the callbacks problems and make your code better. But I would say that they are not nearly as uniform and semantically meaningful, and they don't have the same kind of correspondence to a synchronous control stack that the promises do. Right, right. Yeah, the question was, in my get user example that this is kind of based off, I had to be careful never to return something that wasn't a promise. And that's true, and that's actually a slightly tricky thing to do, because what if you accidentally JSON parsed? So a lot of libraries come up with wrappers. In Q, it's called, it's called bind, I think. fbind. But you can, it'll wrap your function. So you say like var function equals wrapped real function. And that way you can just throw errors or return scalars, and it'll take care of it. It'll turn it into promises for you.
Those last 2 lines combined with no changes.
So this is a very good question. Right, so the question was, can we combine these last 2 lines with no change in effect? The answer is no. Does anybody know why? And you'll get a sticker, a Promises A+ sticker. So Luke knows.
You better know.
Been pounding this into my head. So if UI.showBestFriend throws an error, and the error handler is on that same then, there's nothing to catch it.
Right, that's exactly it. So yeah, if you go back to the synchronous example, this actually makes some sense. So you're doing a transformation, but your catch is a separate thing. So if you combine them together, then it's different. But if you say separately, I'm going to catch any of the previous errors, then this is going to trigger that. Sticker.
Is that a pretty common pattern?
Yeah, this is actually okay. The question was, is this a common pattern? This is an extremely common pattern, and in fact, in RSVP, I should have added a slide for this. And in many promise libraries, there's a method called catch, C-A-T-C-H, like the keyword, that is just this, but you don't have to type this part.
I don't think we have that yet.
Oh, RSVP doesn't. Never mind.
I can't get you to agree on a name.
Oh. Yeah.
I have a question. This might be just relative to the jQuery implementation, but when do you use then versus pipe?
Right. So the question was relative to the jQuery implementation, when to use then versus pipe. Use pipe if you're in jQuery less than 1.6. Yeah, never use pipe. And never use the jQuery implementation, because one of those 4 cases will work. But all of the ones having to do with errors that I showed you will not work. So that's very depressing. And also, the jQuery implementation does not interoperate with other promises. So if you happen to return another promise from your promise, then the bonus async case doesn't work either. So basically, they just fail at life. And don't do that.
Is something being done about that?
Yeah, is something being done about that? Unfortunately, no. They have backwards compatibility constraints. They refuse. I had a long argument with them in the 1.8 time frame, and they were like, nope, sorry. Creating objects is hard.
But lots of the implementations,
Right.
like RSVP, these things, what you do.
Yeah. So yeah, Steph was about to say that all of the implementations really recognize that there are so many unfortunate, misguided jQuery promises out there in the wild, and we need a way to turn those into real promises. So they have a function named like resolve, which the thing about the resolution operation is it's not keyed off of recognizing that implementation's promises. It recognizes anything with a then method. So if a then method behaves even slightly sanely, and jQuery is thankfully like on the right side of that border, you can absorb it and turn it into a real promise. So you do rsvp.resolve jQuery promise, you get back an RSVP promise. You do q.resolve or just q on a jQuery promise, you get back a real promise. So that's good. Yeah.
So is that, I didn't actually know you could do that across the board. Does that not propagate exceptions to window.onError?
Once you get, yeah, well, the question was like, does doing this absorption procedure not propagate exceptions to window.onError? Yes, once you have a promise that catches exceptions and transforms them into rejections, they will not go to window.onError anymore. You will have uniform exception handling semantics across the board. Does that answer the question?
Yes, jQuery, you can undo what jQuery does.
Yes, you can undo what jQuery does. Yeah. I mean, it won't like erase the console that's already been printed, but if you have something that's, yeah. Yeah.
So if you're going to talk about this later, totally fine, but that question makes me wonder about debugging promises, because
Yeah.
I've had a lot of pain around that.
Yeah, OK, debugging promises. Maybe I should switch to this other presentation where I actually talked about this, but I didn't want to talk about it because RSVP doesn't have a good solution. So, yeah. So debugging promises, yeah. Well, use Q. So there's two main pain points, I think, with debugging promises, and one of them is more serious. The less serious one is that your stack traces suck. So you get an error, and you're like, oh, I'll just log the stack trace, or I'll use the debugger. And you end up just like, because of this always async requirement, you end up just, oh, I went up 2 levels, and I found a bunch of promise library guts and nothing else. I have no idea what triggered this. So that's sad. Q solves this by rewriting the stack property on errors optionally to include all of the stack trace information for all asynchronous operations that have been chained. So that's pretty cool. It's a performance hit, so we had to turn it off by default because benchmarks were killing us. But it's an option, and it's really nice. The other problem, and this is kind of the dark secret of promises, is that if you're not very good and you have one of these at the end, right? If I forgot this, but one of these steps failed, I would never know. Okay, so that's a big problem because you're going to do these operations and you're not going to be a Superman. You're not going to say, oh, I will always have a then with an error handler. And that error handler, if that error handler fails for some reason, then I'm screwed even with this code, right? So you need some kind of, so what you need is some kind of universal error handler you can just plop on the end that if there's an error, it rethrows it in the console or puts in a window dot on error or put a whatever. And most libraries have a method called done that does exactly this. RSVP does not, but I think they're planning to add it. But even then, that still requires a lot of vigilance, right? You still have to remember, like there's a golden rule when using Q promises, for example. You always either return the promise to a caller or you call .done on it. So if it's your responsibility to consume it instead of handing it off to someone else, it's also your responsibility to call .done and say, I'm done. If there's an error, rethrow it. And that requires vigilance as well. It's a rule that you kind of get ingrained, and I think I've had some success with it on reasonably large teams. But it still kind of sucks. So what we would like to do, and what I just need to make some time to do, but haven't so far, is create like a bookmarklet that tracks whenever there are promises that haven't been handled yet, that have errors, but those errors haven't been handled yet. And so what that would do is like display you a list of, oh, here's the unhandled rejection reasons. And then they would like get erased if somebody handled them. And then they'd come back, and you kind of see this dynamic errors flowing through your app. And so that would be really cool if I had any free time. But we can do that. We have plans for doing it in a cross-library way that you can use any promises, and they will get in this debugging thing. It'll be really cool if we make it happen. And also the native promises that are coming to Firefox, at least, they have plans for this kind of thing integrated into the dev tools. Yeah. All right, you got a question in the back?
You talked about how a lot of the promise libraries can deal with each other's promises.
Yeah.
Even jQuery can be handled.
Yeah.
Are there any libraries before you provide promises that are on that your side of the same line that are?
Yeah, are there any libraries that yeah, are there any libraries that don't interoperate, can't be absorbed? The only ones I can think of are kind of weird ones that nobody uses, like ones that use the node style callback instead of the 2 fulfilled and rejected. They give you 1 callback with 2 values, something like that, or node 0.1 promises, which were just event emitters and don't actually have a then method at all. So yeah, I think we're pretty safe. It's good. All right. Well, I feel like we got to the end of the presentation because it was question time, which is awesome. But I do have some cool examples. I want to finish up without taking up all the time. So as I was saying earlier, because they're first-class objects, you can do things that tie together promises and give you new promises that are really powerful. So here's an example of an operation called all. And RSVP has this, Q has this, everybody has this. You give it an array of promises, and it gives you a promise that if all of those promises fulfill, it fulfills with an array of the results, right? But if any of them reject, then it will reject with the first exception to happen. So this is really useful if you want to like get 2 things in parallel. This is kind of the fundamental thing that synchronous code cannot do. So I mean, it's pretty nice. You just pass an array, and you get back an array. But you can do other combinators, and this isn't as useful, but it's an idea for like kind of how you can create these generic things, right? if you want to do any of these, like if any of them succeeds, if any of them fulfills, then we'll fulfill with whatever the first result is. Or if both of them reject, then we'll reject with some kind of composite error. So you could build something like this pretty simply. So I mean, I give you a use case here. You're storing data on redundant servers, and if one of them succeeds, you're good to go. Finally, and I think this is pretty nice, you can create functions that accept promises and then wait for the results before doing their actual work. And so what that means is you can have code that looks like this, almost synchronous, right? This write file function waits for all of its parameters and says, oh, well, I've got a promise coming in from this read file function. Let me wait for that before I actually do the writing. So this creates some really nice composable code. And this is kind of the idea that you can pass promises throughout your system, and if you kind of embrace them fully, your code ends up looking really, really clean. Final pieces of demo. I want to just give these two functions that I cooked up that are really cool for kind of just generic things you can do. So if you have any promise and you want to create a new promise that just will time out, will give you a certain error if that promise doesn't fulfill quickly enough. And if that promise rejects, it'll reject. If it rejects within the time period, then it'll reject with that error. So that's fine. So this is also our first example of creating promises, I believe. So you say, I'm going to return a new promise, and you have these functions, resolve and reject. And so we do promise.then resolve reject. So if the promise fulfills, we do the fulfillment. If the promise rejects, we do the rejection. But we also set up something in parallel that after however many milliseconds, we reject with the timeout error. And so what's interesting is these guys will race, and whoever gets there first will win. So if the reject happens, but then these happen later, it'll ignore that. And so this is a pretty powerful abstraction because you have any promise operation, say like an XHR, do XHR URL. Well, now you can create a do XHR with timeout. All it does is just applies the timeout function to that promise. So you now have a promise that will do the XHR, but will also have timeout behavior. So this is really nice. This is a completely reusable timeout mechanism for any asynchronous operation. The other example is retry. I mean, this got mentioned in Ember, where they have their own thing that makes a lot of sense for that. But the word retry triggered me. Oh, well, let me write this. So this thing is a generic async operation retryer. So you give it a function, and it calls, and then it does catch. And I actually probably should have used then undefined for portability. But it does catch, and if we're down to the base case, right? If we've decremented enough times that we've tried, 10 times or whatever, then just rethrow the error. It's a rejected promise. We tried as much as we could. We're done. But if not, then just do this whole thing again, right? Retry the operation with one less max times. So it's kind of like synchronous code, like the kind of recursive retryer you would write, but you're doing it just with promises now. So you don't have to do any kind of like callback mangling to get this kind of abstraction. So if you want to do an XHR with a retry, you can just pass it to this generic async operation retryer that will do any async operation and retry it however many times you want. So that's it. Those are the promise abstraction ideas, and that ends the talk. So. All right. Also, I do have stickers. They almost all fell out. But if you come up and introduce yourself, I would love to spread the gospel of Promises A+.
He promises. Awesome. Do you have time for a couple more questions?
I do have time for a couple more questions.
So you showed the example of all, right?
Yeah.
So that basically will continue once all of them have finished. Is there any way to do something more like, I want to keep going for each one after they finish, I want to keep processing it? Kind of like more of a streaming kind of thing? Is
like
that
a map, you mean?
Yeah, kind of like a map, right? But I want to keep, so the first one returns, what do you want to process that one, while the second one is still doing the first step.
Yeah. But then you want to be notified when all of those processings have happened.
Well, I just want to end up at the end of my pipe once it went through all the processing steps.
I mean, yes, and when actually comes with something like that. When map, it's just a matter of like, does the promise library bundle this kind of helper, or do you have to write it yourself? But as I was kind of trying to show with the subsequent slides, writing these helpers is pretty easy, and they end up pretty generic. I'm tempted to bang one out right here, but it would probably not go well.
Other questions? Matthew in the back.
So you talked about the performance concerns and using set timeout 0.
Right.
And that there are various ways to work around it. Any concerns about using try catch and like a lot of times, and any ways that you work around that?
Yeah. So try catch actually isn't a performance problem as long as you don't do anything inside the try or the catch. So what happens is if you have a function with try catch inside it, V8 and I think others just de-optimize that function. They don't run it through the fast jitter. But if you call a function inside your try or inside your catch, that one is still eligible for optimization. So you have no problems there because all we do is we call your callbacks. We call your unfulfilled and your unrejected. So we take the try-catch burden. We get de-optimized a little bit. But we're doing some very simple stuff. So there we go. Your code, whatever it is, all fast.
I have one question for you. Naming. So every time I make a promise, and if I need to assign it to a variable, I'm like, what do I name this thing?
Yeah. Is it time for the return of Hungarian notation? Let's take a vote. Who thinks yes? Yeah. Okay. I thought that would be what happened. No, I don't actually have a great answer for you. Like back at a project I worked on at a previous job, we named all of our promise returning functions with the suffix async. But after we got, and that was actually a fairly good strategy for our transitional code base as we started moving to promises. But then when we started a new project and kept that naming convention, it just became silly because almost all of our functions had async at the end. But that is the strategy that Windows 8 uses, so that's interesting. Good information, I guess. Yeah, I don't really. I would just name them normal things. Like in certain cases, it might be useful to disambiguate and say like user promise. It certainly is on introductory slides, but I would just call it user. Or often I just don't need a variable for it. I just say like get user.then. So yeah.
Cool. Any other question, Mike?
So one of the things that kind of trips me up with promises, and maybe this is related to naming conventions, but as libraries change and start using promises as opposed to other things, as Ember's start incorporating them, I never really know whether I'm going to be getting back a promise, especially if I don't even remember what version of Ember I'm on. And so how do you deal with that? Like you're using random libraries, you maybe don't even know the library that well, and if you don't have a promise, then you can't just kick it back as your return value and you're going to mess up the whole call chain. So are you just always wrapping things anyway just to be safe? Or are you actually looking at their code, or are you reading docs, which nobody does that?
I mean, so I think it's a little bit simpler than that. I think you use a library that either uses promises or uses callbacks. And if you use a library that uses callbacks, you're going to need to know how to deal with that anyway, and whatever. But if you're using a library that uses promises, you can pretty much ask yourself, is this an asynchronous operation? And if it's an asynchronous operation, it's going to return a promise. And Ember does have a lot of magic stuff where it's like it's going to hook up stuff for you, so it's not really asynchronous. So that may make it harder. But in normal code, at least, it's pretty easy to say, oh, this one's going to the server, so that's going to be asynchronous. It's definitely going to be a promise.
I guess I see a bump happening more over time as more and more libraries incorporate and start doing more magic things that you don't know.
But are those magic things asynchronous or not? Like it's a pretty, usually you know, but maybe not. I mean, I understand your pain. And
I guess I'm just kind of worried about how it evolves, because if we depend on knowing what the code we call does in order to know whether the code we're writing is.
But you already depend on whether it returns you an object or a scalar. Like you already have some knowledge of its return type, right? Like it's not that different. It's not a completely transparent abstraction. There are languages in which it is, and that would be really cool. But at the same time, if we did have that language, we would never know if we were going off to the network or not, because we have no way of denoting, oh, this is async.
So is this syntax represented today the one that's being standardized in ECMAScript 6?
Yeah, the question is this syntax I presented today the one that's being standardized in ECMAScript 6? No, it's being standardized in ECMAScript 7. But yes, it's exactly this. Like the promises A+ specification, which grew out of the efforts that we've done in Q and RSVP and WEN and others, essentially they just adopted that for the DOM promises, which are forming the core of the ECMAScript 7 promises. It's interesting, the ECMA standards body moves too slow, so they had to get things in the DOM. But they made sure that whatever they do there is like core semantics are correct enough that ECMAScript will feel fine taking it over in a couple years. Yeah. Speaking of ECMAScript 6 syntax, I won't get into this too much, but there's these new things called generators. You should look at some of the things people are doing with promises and generators. It's pretty awesome. New syntax that makes your code look almost synchronous. It's like C#'s await, if you've seen that.
Cool. Awesome. One last question. Anybody? Are we good?
All right.
Awesome. Thanks so much, Dominic. Appreciate it. All right, we've got one more talk tonight. While stuff is getting set up, I want to invite you all to take a stretch, grab another drink if you'd like. There may be some pizza left in the back, but do it quickly. Also, if you need, there's a bathroom right back here past the exit sign.
Yeah.
All right, ladies and gentlemen, the slide is up. The AV is working. The speaker is ready. So our next and last speaker for the night is a member of the Ember.js core team. Is my colleague at Yap, and is one of the hardest workers on the Ember team. If you have opened an issue on GitHub for Ember or Ember data, there's a very strong likelihood that this gentleman has commented on it or closed it politely, or even solved it for you. On our team at Yap, Steph has really led the charge in terms of integrating promises, using them right, getting away from jQuery promises, which is where we started. For that, I thank him. And for what he's about to share about promises in Ember, I think you all will thank him. So with that, Stefan Penner.
Hello, hello, hello. Well, Dominic did a fantastic job, and yeah, that's it. All right, Luke had an idea that this talk was going to be called The Promised Land. Turns out. Anyway, so I'm Steph. I'm Stefan Penner on Twitter. I'm pretty inactive, except occasionally when I find some crazy JavaScript shenanigans. Like today, where I was for some reason recursively inside so many iframes that I couldn't find the top anymore, actually. My GitHub is Stefan Penner, and if I've accidentally closed an issue that you've opened and you feel strongly that I should not have closed it, buy me a beer, and we can probably talk about it. I work at Yap with Luke. We have lots of fun building lots of fun things. Our time is split between the product Yap and Yap Labs. Yap Labs, we primarily do Ember and related technology consulting. This is anything from exercising very experimental technology stacks to helping people with general Ember problems, everything from mobile performance to Ember data bugs to other things. Yep. Anyway, so when I talk, I like to have a little bit more of a conversation. So if you guys have questions or concerns, just yell out. We'll talk about it. But wait, one sec. But be mindful, because a few of us would like to, at least in the next 30 minutes or so, start leaving to grab some beers. And at that point, with some beers in me, I'll talk for hours.
Yes, my question is, so if I was doing Ember last month, how much is this going to change the way that I code Ember next month?
So the question was, if I was doing Ember last month, how much is this current presentation going to change how I write Ember today? So that question is entirely based around how much asynchronous programming do you do in your Ember application. If you do a lot, and you haven't been using promises, you will likely migrate in this direction. If you haven't done any asynchronous programming in your Ember app, I'm kind of concerned with what you're doing. But it's totally possible sometimes. Ember is a very declarative framework. Often you don't even realize you're dealing with asynchrony when you have it. Promises provide a fantastic foundation for reasoning about things that are very, very hard to reason about otherwise. So this is the plan today. We're going to talk about the promise. Well, actually, I'm not going to because Dominic did that already for us. Yes. Yeah, when Luke was like, you should give a talk about promises because all the promise work you're doing. I'm like, I'm going to get Dominic to explain all the hard stuff. And I'm going to come in and be like, well, they know everything already. Show them a couple pretty examples and walk away, get some beer. Going to show some neat stuff with promises, some real-life examples with promises, some best practices, and then inevitably what happens when you're a software developer and how promises can help you out with this. And then finally, some debugging with promises. That will likely happen with beer. That is very important. All right, so hopefully you listened to Dominic. He had lots of great advice. He's put a huge amount of work into this so that others like myself can really benefit from guarantees that make sense rather than haphazard guarantees that you can't actually build anything reliable on. So what is Ember? What is Ember? Oh, you, the guy behind you.
A framework for creating ambitious development.
That's right. Would you like a then sticker? So Ember, as hopefully everyone here knows, is a framework for creating ambitious web applications. And not just creating them, but trying to hide some of the pain points while creating these ambitious web applications. And as it turns out, managing asynchrony is a huge pain in the butt. Managing asynchrony in a sort of serial state, like I would like to do X, then Y, then Z, and it happening in that order is not that much of a problem. But when you start building more complicated applications where some things are in cache, other things are not in cache, some servers are slow, some servers need to be retried, it turns into a huge nightmare really quickly, especially when you're many layers removed from the actual data access. And at the very end, you just want to use Alex's recent router fixes to display either yes, it worked or no, it didn't. And you don't care how many random things happen below you. And it turns out managing this complexity is a huge pain in the ass. And so promises basically have this neat property where rather than increasing entropy, as you saw with Dominic's examples, where using the callback style or similar programming styles, the complexity really just balloons out the more things you're doing. With promises, it has this guarantee to give you a binary response for yes, it worked, and here's the value, or no, it didn't, and here's the reason why. Now, there's some tricks to really maximizing this, but that guarantee is awesome. It doesn't matter how crazy that graph is that you've done. You can be talking to actually 1,000 different things. At the very end, where you care about it, in the router, when you want to say, yes, it worked, here's the stuff, or no, it didn't, here's an error message, you have now managed the complexity. So I'm going to talk a little bit about RSVP.js. So RSVP.js is basically a promise implementation written for Ember. It has some unique properties that allow it to utilize Ember better. But all in all, it's very similar to a lot of the existing implementations. The guarantees are the same, and thanks to Dominic, the functionality is pretty much where it matters, the same as all the other compliant implementations. So the TLDR, if you've used other implementations, and I was actually assuming Dominic wasn't going to show any RSVP examples. So I was just going to like translate Dominic's stuff into mine, but he already did that work for me, so we can basically skip it. Anyway, so there's some, when you're using RSVP, it provides a RSVP resolve or RSVP reject as a top-level method. And here's some basic examples. We're going to go through them pretty quickly because I think Dominic has covered them pretty well. Does anyone have any questions about, or should I just skip through a few of these?
I would think you should talk through them.
Sounds good. I'll talk through the first one, and if you guys are bored, just tell me. I'll keep going. All right, so when dealing with primitive values, when a promise resolves a 1, for example, it will then fulfill with the 1 as the value. Surprise. If, in fact, you reject with anything, in this case I used an error, it will, in fact, reject with, guess what? That error. Now, it does become a little bit interesting because you can actually resolve and reject with other thenables. A thenable is just another name for a promise. If, in fact, you resolve with a already resolved or will be resolved thenable, you will then fulfill with that resolved thenable's fulfillment, which in this case is 1 again. And the same is actually true for the error case. So if you resolve, Dominic, you look like I have mega doubts.
No, you are actually saying these things correctly, which is very exciting. Nobody says resolve correctly.
So, little backstory. I'm from Canada, and a boot, took. And like, for many years, I had like 6 people around me that I could actually have conversations with. And probably the only reason I could have conversations with 5 of them is because they seemed somewhat interested, and I basically forced them to listen to me. And the other one was the same as me, so it worked out fairly well. So I'm super excited when the people that are doing stuff are in the same city as me. So I was like, promises. Dominic lives in New York. Dominic, we're getting a beer, and we're going to solve some of these super annoying problems. And we've hung out a few times, and I think we've been able to shape how Ember is handling promises. And in a few cases, we've been able to dictate some of the A+ spec or enter in an idea and then realize it's a terrible idea and leave it. But leave it with real-life examples and real pain points. So that's super exciting. So we got to buy him some more beer tonight. All right, so the fulfillment handler, the first one. Its return values propagate downstream. So if you return a value from it, that return value will go to subsequent fulfillment handlers. Kind of like when you return from a function, seems legit. So returning a promise from a callback assimilates. And well, when I first read this, I was like, what the fuck? But it turns out this is actually kind of useful. So if in fact you return a rejected promise from the fulfillment handler, it will turn into that returning promise will become a rejected promise. Now this seems like great stuff, seems totally not applicable, but I assure you, in fact, this primitive is super awesome and super useful. I remember seeing this, I was like, I don't even know what's going on, nothing's working, stuff is being, anyways, if you can get over some of this initial complexity, the amount of complexity it totally washes away from your system is huge. So bear with me and ask questions as needed. This works with both the fulfillment and the rejected promise handlers. So if in fact you return a fulfilled handler from the rejection promise, it will become fulfilled. If you return a rejected promise from the rejected, it will continue to be rejected. And if you throw from the rejected handler, it will continue to be rejected. This is important because if you return a resolved promise or a scalar value from the rejection handler, it will all of a sudden become fulfilled. And all of a sudden now your failures become successes and the world is upside down and bad things happen. That's the rejection handler if you haven't caught on. Oh, damn it. There's a slide. This is an important caveat. I spent a lot of time, especially with people doing Ember, who are having initial pain points with promises, helping them debug, helping them build more resilient code. And this is almost always one of the gotchas. And I know it was a gotcha with me, where I had a success handler, and if an error occurred in the success handler, my failure handler didn't get it. This made no sense to me until I went and figured out what the fuck was going on. And it turns out you need a second handler. You basically need to then put a then at the end of this and give it a rejection handler. The best way to make sense of this is to try and write this out as the equivalent try-catch code. And it will be immediately apparent why this is important and why this actually makes sense. But the best example is, imagine you do a user find, and your user find has 2 code paths. It either succeeds or it errors. Now imagine if in the success handler, you do some other asynchronous stuff and it errors. Why would the code that handles the user error care about this other error that occurs? It makes no sense. So again, the first time you look at it, you're like, this is crazy. And then when you think about it in sort of the larger picture, it's like, yeah, actually, I'll make this trade-off. It makes sense. All right. So RCP has something useful that Dominic pointed out, although he missed an important thing. If, in fact, you pass a scalar value, like the string Steph, in as an argument, it basically just passes through RSVP, and RSVP just doesn't really care. It doesn't need to do any work on it, so it just passes it right through. On the other hand, user find, in this case, will return a Venable that does an AJAX request, fetches a user. So when user all completes, it fulfills with a value of Stefan and the user object. Stefan took no time to fetch because it was already there, but the user object took a known amount of time.
You can pass in any Venable, so jQuery promises will get turned into, they'll get fixed.
Yes. So if, in fact, you have any Venable, it could be a Q Venable. I wouldn't use Q. Or a when Venable, or even object that says then, or a jQuery Venable. It will get converted into an implementation specific. So the current implementation is Venable and executed. Now, there are some caveats. If, in fact, you have a big complex graph of jQuery promises and a top level, or actually just a few steps away from you, errors before you are not going to be saved by any heroics this other promise library will do. So it's very important if you're wrapping jQuery, which I'll show a little bit later, you wrap it right at the source. The further away from the source you are, the more problems you are likely going to face, mainly around exception handling and sometimes, some implementation, the order that stuff executes in. So just to save gray hair, not have to worry about debugging and crazy errors, try to wrap these promises, if you need to use them, at their base, right at their call site, their initial call site. So time for the contrived but somewhat useful example. So system requirements. Visit articles, fetch the current user, and fetch that user's articles. Seems legit, seems right. The implicit requirements are basically handle the errors. We want a resilient piece of software. We want to handle concurrent async. Essentially, any async that we do can happen in any order, and we should actually not care about this. As long as it all ends up finishing, it should work. Or even if one of them fails in any order, we should be notified correctly. And the most important thing with software development is that it's forward maintainable. So as requirements change, you're able to still have maintainable code. Whereas that crazy try-catch stuff becomes very hard to maintain. The goal is we need to make software maintainable. So assuming nothing, no Ember data, none of the shenanigans, let's build something. So is this readable? I'm going to break this down a little bit. So this basically is a very simple promisified AJAX method. That I have swapped for the wrong promisified AJAX method, but I will do live coding and fix it. Anyways, we'll talk about this one. I'll talk about its shortcomings, which is very important in the Ember world. But anyways, so we're basically still piggybacking off jQuery's AJAX, because they do a lot of stuff for us we just typically don't care about. All that we do is we override the options success and error handlers. We resolve and reject accordingly. So the API becomes app.ajax, URL, options if you need, then, and it fulfills with the data or rejects with one of the many things jQuery's AJAX call rejects with.
jQuery does not realize that
anything.
Functions only throw one error.
Yeah, we experience this pain every time we look at AJAX. Anyways, so a really important thing to realize is if you don't have Ember installed on the page and you use RSVP, or even if you bring your own RSVP with and you don't touch Ember's RSVP, that RSVP is going to use async. Now, all promise implementations that are compliant need to implement some sort of async, but they can all implement different async. And between different browsers, that async will be different. So for example, on a really crappy browser that only has set timeout, you'll likely get set timeout. On more advanced browsers, you'll get mutation observers doing the async, which are really fast, or even faster, you get something like set immediate or post message. So by default, RSVP will use a browser mutation event, but if in fact you are using Ember's RSVP, so Ember.RSVP, we have a hook in there so that it uses Ember's run loop. So there's no going back to the browser. It will just queue it on the run loop, which means in practice it is insanely fast compared to many other implementations. This is a perk of using Ember. Anyways, but there's a slight issue with this. That means every time you use an Ember promise and they resolve and reject, they will potentially cause auto runs if they're not wrapped in a run loop. The reason there's an auto run is the way Ember works. Majority of Ember really relies on the ability to defer actions, so they're coalesced later, which seems crazy, but it actually brings sanity to the mix and allows you to do some really powerful things. So when this resolve or this reject is invoked, Ember will queue it onto the actions queue and execute at some point in the future. Now, to make this Ember safe, you basically want to say, hey, look, I'm going to wrap it in an RSVP run and also an RSVP run. Now, it's important if you're using external async in Ember, such as WebSockets or mutation observers or post message or Ajax, or other libraries that provide some method of async, that you wrap right inside the callback, right at the root of the callback, you wrap that in a run loop. This ensures that any Ember code that's inside, that's triggered because of this callback, will be inside the run loop and everything will work wonderfully inside of it. Any questions?
You should be able to fix that, right? Like, you should make RSVP configurable so that Ember can do this to its copy or something.
I was just going to ask the same thing. Like, if we're putting it on the run loop, can't we just automatically wrap?
So the question is, if we know that Ember promises are going to be on the run loop, why can't we just always bring a run loop with? Well, unfortunately, you can't, and sometimes you don't want to. And I thought this first too. And I'm like, oh man, I have the perfect way. We don't have to worry about this anymore. And I went and pushed it in there, and then I showed it to Chris Selden, and he's like, Steph, have I taught you nothing? I was like, I guess not. Basically, there are some situations. So basically, you always want to put the run at the bottom of the frame, as close to the bare metal asynchrony that happened. And occasionally, and lots of times actually, your promises resolve much higher up. And it actually turns out that there are some scenarios where you can't predict if you should be creating a run loop or not creating a run loop. And you would basically cause some situations where you would think you're doing the best thing and actually turn something that should have been async into a synchronous call. And that is not cool. Those cases are far and in between, but this just works in every situation. Ideally, in your application, in any place where you do async, you're aware of this. You wrap it at that one leaf, and then you never think about it again. I guess another question that I guess hasn't been asked. What is the downside to an auto run? The downside to an auto run is they're significantly slower. That's not a big deal. But sometimes they can cause strange interleavings and hard to reason about problems. Most of the time they work correctly. I wonder sometimes if they should even exist. But probably to interact with your app in the console, they're quite useful. All right, so given an Ember route, we want to implement the requirements. And the requirements were, when I visit the articles URL, fetch the current user and the user's articles. So given that we have an app Ajax method, let's build stuff. So app.currentUser fetches the current user based on the current user URL, returns the that will fulfill with the data from that resource, or reject with one of the 1,000 things jQuery will tell you failed. The articles, it's fairly simple. Article has a by user ID method on it, which given a user ID, it will fetch the data at articles user, returning a promise that will fulfill with this. The route now becomes app.currentUser, then, well, I don't need to read it, you can see it. It's relatively clear what's going on. Any questions? Nope. So testing the happy path. This is where, so this is neat because it doesn't matter if current users cached or the articles are already cached, or what if the articles have a TTL, they'll invalidate it in the future. You don't care the order, it doesn't matter. This will always behave exactly the same way. It might take a little bit longer in some situations where a round trip is required, but it totally hides the implementation from you, but it is incredibly declarative into what you need and what you want and defining the temporal dependencies between things.
Steph, do you want to explain what Ember does when it sees, when it calls this model?
Correct. So Ember will detect if you return a thenable, anything that has a then on it. And if in fact you do, it treats it like a promise. And the default behavior is that that route that you're in will basically end up in a loading state of sorts. And it'll wait until that then fulfills or rejects before it leaves that loading state. Alex will talk about this quite a bit in the next talk. Is that?
Yep. Is this new with the router facelift, or has it always been?
Yes and no. So the question was, is this new with the new router facelift? So the easy answer is, you can now use it consistently this way. The idea initially was this, but there were some scenarios that basically made it somewhat useless, where this wasn't handled quite correctly. So Alex was able to take this awesome idea and make it consistent and work from the various different angles you can imagine. Do you have any? Nope, seems good. Answer your question? Perfect. The cool thing is if this rejects, it goes down the rejection path. If this passes, it goes down the passing path. And you don't actually have to attach this failure handler that you have to do with many promises because the framework handles that for you, which is quite important. So testing the happy path. Bear with me, it's a little bit of code, but it kind of shows how simple it is to then test this particular route. You simply instantiate the route, create some fake data, create some fake promises, and at the very end, route, invoke model, then assert correct articles. You have the assertion here, done. You've now tested this async code. Luke, you look like you have a question or you're pondering.
I'm reading.
Okay.
I was struck by the term fake model, fake promise. So what do you mean by a fake promise?
I said fake promise? Oh, so basically rather than relying on jQuery's AJAX, we're instead just going to use RSVP resolve to provide fake data from a backend that we're not currently exercising in this test, because we don't care. We don't care where the backend data is coming from. We only want to exercise that this model hook in the route works. Now, this one's fairly simple. Maybe it is worth testing. Maybe it's not. That's up to you and your team and whoever you pray to or not pray to, whatever. But inevitably, some of these things get quite complicated, and it's important to understand how to test these.
Yeah, it is a very common, like writing tests, overriding a mock to return a resolve, just Q.resolve, RSVP.resolve.
Yeah. So what Dominic was saying, this is a quite common pattern, but it's something promises enable, because you don't care how the asynchrony works. They basically have a very simple external API, and they have specific guarantees, so it's super simple to now have a mock for anything that's async. As long as you know what the success case is and or the failure case that you're testing, you merely insert that promise into your test as a stub or a mock, and you can now test your wiring logic to make sure that it worked correctly. In this situation, yes.
Right, so basically, if you're running a test in parallel, you're going to be screwed.
You can.
Right, because you're overriding app current user here to one thing, and then you may in another test override it to another thing. And if the tests ever run in parallel, like you can never run your tests in parallel.
This is not true because you could easily have that app not be global. So in our applications now, our new ones, we're using ES modules. So app could have just been hoisted to the top and it's local to this particular closure. In addition to that, in QUnit, your tests don't run in parallel, and you don't really want them to run in parallel. So what actually happens in this test is I'm stopping test execution, waiting for this to finish, starting test execution, continuing on from here.
Right, but basically, whatever code you're testing is going to refer to the same global app.
Whatever code I'm testing is going to.
The code under test, right? The module under test. The code that you're testing, right? It's basically using the app, right? It's looking for the current user on the global app object, right?
Well, it's only, so this test only implies it's local to this particular file. I've not described a module system or not module system, so there's no way like.
You understand, but you're overwriting something. You're saying after current user is something, right?
Correct. Oh, what you're saying is, oh, now I've overwritten it for everybody else. Exactly. Correct? This actually totally includes a setup and teardown on top, but I ran out of space for this. So essentially, I restore this method once it's completed.
Okay, but I guess my question is more like, could you have something where you don't have a global app?
Yes. Yeah, you totally can. Okay. Yeah, and this is just for like simplicity. So I can show you some great examples of writing an Ember app where you have basically no globals. Okay. This is sort of been convention, and I'm pushing it in actually a direction where that isn't the case anymore. But I think we are totally aligned on the goals here. Seems good? Yep. All right. So now testing the negative path is actually ridiculously simple. You just change the resolves to rejects in random orders and see if your code fails. Exercise for the reader. This brings up an interesting thing. It is very important to wrap entire chunks of code in these promise callbacks so that if something errors via a JSON parse, for example, a malformed piece of JSON comes back from the server, like transload it for some reason telling you that here's some valid JSON, that's not JSON. You can still capture that and bubble that error up. So best practices. If you name your handlers, if you have only a few handlers, this might not be a problem, but it's actually really useful to name your handlers because you can really express your intent. And a good example of this is actually the work that Alex did on the new router, where he describes essentially the entire flow of the new router in a series of thens. I think to the right of this is a great place for some comments.
But it's so readable.
But it actually really is, because now we've turned what normally would be a series of insane try catches and stuff into only a few lines of code. It's almost like we're back to the synchronous world where you could call A, B, C, D, invoke them in the order that you expected them. So name your handlers to prevent ambiguity. This is very important. As Dominic brought up, if no one's listening to failures, no one is ever going to be told that there's a failure. And it's quite easy to end up in a situation where you boot up your app, you got a white screen, and no errors. You're like, what the hell's going on? There's a few really neat tricks that you can do this. So in an Ember app, what I do quite often if I run into this, and I've been going through the framework and a bunch of other frameworks that are used and making sure that these are installed where applicable and where not applicable, or having the framework do as much as it can. And a great tool for doing this is the blue debugger button in Chrome DevTools. Now you guys are like, but Steph, when I turn that on, I have to click next like 1,000 times to get out of all the browser sniffing stuff. Well, if you move a debugger into your app ready, don't enable the blue debugger until the app ready hits, then engage the blue debugger. You've skipped all of these insane browser sniffing try catches, and now you can proceed forward. In addition to this, I was talking with some of the Firefox devs, and they're working on black boxing, enabling users to opt into a black box effect. So you can basically black box framework code from catching these try catches, which is awesome. So all of a sudden, like all those stupid browser sniffing things that make it almost unusable to use this blue error will now not interfere with your blue error if you don't want it to. The idea is to have a checkbox to enable or disable this. In addition to that, they're also working on stitching the stack traces together between async steps, which is going to fix a whole set of problems when dealing with these promises. And same thing for promises. Failure, no one's listening. No one will know if it happened or not. So please, when you know that you're at a terminal node in the promise chain, install a rejection handler. We're probably going to add something like done or catch. Just have to figure out a name that makes Yehuda happy. Who's ever worked on a project where requirements didn't change? No, okay. All right, so basically the requirements change. In order to fetch multiple records, we now have to query multiple backends. So crap, that sucks. Turns out it doesn't suck that bad because we have a nice boundary, we have a nice set of boundaries around our app. So as soon as we fetch by user ID on articles, we merely query the 2 backend servers that we need to. We imply that there is a flatten available to us. And the rest of our app continues to work as it did before with no changes. All the error handling, all the async, everything, nothing changes. What's flatten? Who asked that? The question is, what is flatten? Flatten is a method that you have written yourself that flattens arrays. It's fairly simple to implement, but I didn't feel like adding that as an example here. Basically taking n arrays of arrays, it'll turn into a single array. And given that RSVP all will return an array, and service A and service B will fulfill with array values, if we just flatten them together, we now also have an aggregate across these different services. In addition to that, all will fire these things concurrently, which has some neat properties too. This is super maintainable. With these boundaries and these consistent APIs, super simple to swap out components of code without having to worry, hey, did I just screw all my downstream consumers? They only rely on the then, they only rely on the data that's coming to them. As long as you can continue to provide that to them, the entire implementation behind it is entirely irrelevant, and it should not matter to the consumer of the API. Except that if they consume the API, they need to attach a rejection handler. So something useful that RSVP provides is something called hash, which is very similar to array, RSVP all, I mean. Except rather than it consuming an array, it consumes an object. And as you guys can imagine, it's quite neat for building pipelines where one object will eventually continue to grow and become an even more complicated object, where some values are async, they're thenable, some are scalar values. At the very end, you've built this pipeline of dependencies. You've declared the dependencies, and by the very end, you end up with either all of them together or the reason why it didn't work. So debugging tips. I gave one debugging tip already. Another one is pretty much that one. It's super useful. There's also a library that exists that's cross-platform stack trace stitching, which I think I'm likely going to add to a debug build of Ember and a debug build of RSVP. One of the suggestions was to remove try catches from RSVP. Unfortunately, this is painful in many ways, where actual legitimate code will fail. And Dominic looks like he's about to cry because I'm even suggesting this. But today I actually recommended to someone do this. They're debugging in IE8. And
you just have to attach Visual Studio.
and they're debugging in IE8. But there's actually a third-party library that does fantastic stitching together of these stack traces, which is likely going to be added to a debug build of RSVP. If you find crazy bugs in libraries or framework tools that use RSVP or promise-like libraries, and you can't seem to debug it, with the one strategy I suggested to you, let me know. It'd be an interesting challenge. But typically, that's a great way of figuring out these issues. And don't forget to attach the rejection handler when you are done consuming a promise and there's no downstream consumers. I think in the last 2 weeks, I've actually done like, I don't know, probably like 10 to 20 commits across a bunch of different libraries, just adding these types of handlers in them, because Anyways, so if you have any questions, let me know. Or we can go to the bar and get beer. And then questions can be answered and asked there. But if there's any questions, feel free to ask. No.
Questions for Steph?
You mentioned a library for exception stitching that you were considering adding in. Which one was that?
It's in my browser history. I can tell you afterwards.
Probably JavaScript stack trace.
Why can't I see this? Yeah, so it's called JavaScript stack trace. The question was, what was the library I brought up before about stitching these things together across a whole myriad of browsers that I would personally not want to make this work on? So someone has done a lot of work, and I think we're going to benefit from it shortly. Any other questions?
All right.
Awesome.
Thanks so much, Steph. And thank you all for coming. If you'd like to come get a drink with us, don't be shy. We're going to Linen Hall, 101 3rd Avenue, between 12th and 13th. That's Linen Hall at 101 3rd Avenue, between 12th and 13th. I hope to see many of you, if not all of you, on the 26th. That's next Wednesday at Harvest for the Ember Core team fireside chat. And then we'll be announcing our July date for this meetup, our regular July talks, very soon. Thanks all.